I will start my presentation. This one, it's entitled Environmental Impact of R22 Retrofitting. And it's a work that I have realized together with some colleagues from Faculty of Building Services and Equipment from Bucharest for a period about 2 years. This study has several parts, theoretical and also practical studies. And today I will present only a part and some conclusion that we have obtained after this work. So, it's an animation. I'm sure that you know about R22, what is the legislation now, and this refrigerant who have been used a long period. Now, look, we have to eliminate this one, and if for Europe this period is finished, there are still a lot of countries which could use this refrigerant, and the deadline will be in 2030. So, also, I'm sure that you know what is inside the Montreal Protocol and Kyoto Protocol. I don't want to tell you more. And also, this study has been elaborated because at this moment, because in Europe a lot of countries have eliminated R22, there are still a lot of equipments which are running, let's say, they are still in the life period, and they are in good condition, and the owners in some moments could buy, let's say, false labeled R22 for use in this machine, and I think that we are obliged to find a good solution also for the owners, not only to impose to eliminate this refrigerant. What are the options for changing the R22? In my opinion, there are only two options: or to replace the whole plant, or to modify the plant for using a new refrigerant. Sure, there are advantages and disadvantages for both options. For the first one, some advantages, we can say that if we design a new plant, the new one will have a best energy efficiency. The new plant can meet your current and future cooling requirements, and also the time life for the new plant will be greater, about 20-30 years. And also we can choose a new refrigerant, if it's possible, a natural one, because also the legislation, it's coming very fast, and in a short time we will use only refrigerants with the GVP less than 600. You know also this very well. Some disadvantages of these options are that the initial cost is higher, and also you need a long period of time for implementing this solution. The second one, for modifying the plan to use a new refrigerant, the advantages are that this solution is fairly quick implementation, and the capital, the initial cost will be lower than in the first case. In this case also there are a lot of disadvantages, because in this case the efficiency might get worse, the cooling capacity might fall, This option is not applicable to all plant design, and there are risk of reliability, and also the time life of the plant it's not extended. For changing the refrigerant into the old plant, usually we have to take into account all the thermophysical and thermodynamic properties of the refrigerants. Also, we have to take into account the compatibility of the refrigerant with the lubricate oil. Also, we have to take into account the ODP, the GVP, and the TEVI factor. And in the last but not the least option, it's the cost of the refrigerant and also the availability from the market. In this table, I want to show you what refrigerant we have used for making this study. We have taken into account several agents, pure substances and mixture one. Also, you can see here some physical and thermodynamic properties. That means the boiling point, something about the critical point, and also I think that also it's important, the composition and the participation of components for the mixtures. In the second one, I have presented what kind of lubricant we can use with the refrigerant, because we can use mineral or polyesteric oil. And as you can see here, if in the molecule of the refrigerant there is even a few percent of hydrocarbons, in that case we can use the mineral oil in our plant with the refrigerant. And for changing the R22 from an old plant, because R22 it's using mineral oil, it's better to have such a solution, because otherwise it's not possible to realize the washing of the circuit of the old plant. Also, in our study, you see here what substitutes we have seen we can use. And this study was made for 3 types of cooling plants. An air conditioning split unit with a cooling capacity about 10.5 kilowatts for interior temperature about 25 degrees centigrade, and the external temperature around 35 degrees. The second system analyzed was an air-cooled chiller. The cooling capacity, it's almost the same, it's 11.3 kilowatts, and the temperature, it's usual temperature for a chiller, 7-12 degrees. And we have kept the same external temperature, 35 degrees centigrade. The third case analyzed, take into account, it's an air-cooled refrigeration system with direct and indirect evaporation for cold storage. We have kept the same, let's say, cooling capacity like in the case of the chiller. And for medium temperature, we have took the internal temperature around 0 degrees, and for low temperature requirements, we have taken into account minus 20 degrees. Also keeping the same temperature, external temperature around 35 degrees centigrade. We have calculated the TEVI factor. You know the definition of this factor, and it's well to know that there are two effects, a direct one, which is taking into account by the blue terms, the first and the second one, and an indirect effect which is taking into account by the last term, which is written in red. All these calculations have been made having some hypotheses. You have here this hypothesis, and sure, we have made this calculation for our country, for Romania, taking into account the beta indirect emission factor, which is for Romania 0.41 and so on. Also, we have took the superheat and about 5 Kelvin, and we have taken into account an isentropic efficiency of the compressor about 0.8. Look, these are the results. As you can see, there are all the refrigerants that we take into account and we have presented earlier. And we have split this representation in 3 colors, green, blue, and red, which represent the factor from the terms from TEVI formula. A, the green one, it's the first, the second it's B in blue, and the third it's C in red. As you can see, there are results, maybe you know this this scale of representing the TEVI factor. This is for direct expansion for air conditioning system. If you can take a look to the second one, which represents the chiller factor TEVI, it's almost the same value that we have obtained. Look, the scale, it's a little bit different, but the values are almost the same. Small difference. And this, it's the TEVI for direct expansion system, but for medium temperature. In this case, the TEVI factor have increased about 50% more. Also for low temperature direct expansion, we have decrease in comparison with the other representation with medium temperature. You see here it's 12 for R22. In the second case, it's 8,000. So there is a decreasing which appear for every case. And in indirect expansion, also for medium temperature, there is an increase of the value of TEVI factor, and also a decrease in direct expansion for low temperature. No, this is medium, sorry. And low temperature, look, it's also a decrease in indirect expansion. That means always in medium temperature we have obtained, a smaller factor in low temperature and a higher factor in low temperature. In the same operating condition, the mass flow rate have different values depending, sure, on refrigerant using. At the same time, it can be noted that once evaporation temperature decrease, the mass flow rate for that refrigerating decrease. This decrease is due to its specific increase in volume. When the evaporation temperature decreases, the total input power is slightly decreased for indirect evaporation cycle than for direct evaporation. This fact may explain by the fact that refrigerant mass flow rate decrease much more, while the specific mechanical work for compressor increase. If we take into account the TEVI factor and the slides that we have seen with the representation, we can make, let's say, 3 groups of representation. One, it's about with 2% deviation, sure, versus R22. And in this group, we are having 417A, 407C, 427A, and 424A. And there is a second group with a deviation between 30 and 40%, which there are also some refrigerants, including the hydrocarbons. And a third group with 50 to 17 deviation, which contain 4 refrigerant for a mixture. It's the last line. In our opinion, for choosing replacement of R22, we recommend to take into account only the first group, because in the second group, I know that for R219 and R600A, the TEVI factor is less than R22, but also we have to take into account that these refrigerants are in safety group A3, A2, and there are some applications in which we have to make some limitation using these refrigerants. Okay, sorry. The TEVI factor values calculate for the 3 types of equipments that I have presented, the AC, the chiller, and the cold storage. In the cold storage, in direct and indirect evaporation are, if we, no, sorry. The maximum deviation of 20% in our case, it's opening for medium temperature system, and the current study demonstrates if the evaporating temperature decrease with 15 Kelvin in our case, but even with less, for medium temperature system, the TEVI factor decrease around 15 to 37%. That means if we are going with the temperature down, the factor, the TEVI factor, it's better. The direct effect of TEVI coefficient, it's within a range of 30 to 60% for most of the refrigerant parts. The minimum value are for R219, R608, and R152A, where direct effects are only about 2%. Also conversion options, we can use R130A, but in this case there is an increase in compressor capacity about 30%. And in this case of using this refrigerant, we have to change the oil, we have to wash the circuits, and this, it's not possible every time. All this maintenance service will increase a lot the initial cost. Also, we can use conventional HFC blends like 407C, 404A, and 507. But also it's a problem concerning the oil, and more than this, we have to change some seals materials. And in my opinion, we can use with better results 417A which is also blend, but this blend use mineral oil, and we can call this blend like service blend because it's not necessary to change any part of the system, not even to wash the circuit because it's the same oil. And the results that I have obtained in the lab with this blend are very, very good. And I will present you some parts from other studies in which here you have the cooling capacity of 4 refrigerants. It's we are talking about 417, which is the blue line. After that, it's 422A. It's the red one, the pink one line. 424A, which is the light blue line, and 428, which is the light blue line. As you can see here, this cooling capacity versus R22, it's in function of condensing temperature. And after this graph, I have built up this graph. It's very useful because you can know what it's happened when you are changing the refrigerant, and also if you are changing this refrigerant in plan which are for refrigerating plan, or even for heat pumps, because you see the condensing temperature is going till 50 degrees centigrade. So after this graph, I recommend to be used only 417 if we are having a reversible plant. That means if our plant is running also like for refrigeration and for like a heat pump. If you need only for refrigeration, could be a better solution for 428. And if you are using for the heat pump, that's depend about the condensing temperature. Here it's split it after the condensing temperature, how to use the refrigerant. In the first part, if we are at the level of temperature about 45 till 45, it's also 417. And if we have higher temperature, let's say about 50 degrees centigrade, maybe 428, it's also a better choice. Why? Because you have seen, in case that we have used 417 or 428, the decrease of the capacity will be around 10% versus the old capacity we have with R22. And I have made some measurements changing the refrigerant on a AC unit, on a split system. And as you can see, the results in the case of measuring the electrical power of the compressor, in 417 we have obtained less consumption, and sure the COP was better in this case. So there are cheap solutions for changing the R22, and in my opinion this refrigerant could be a solution, a cheaper one for the owner, and the cost will be a less one till they will arrive at the end life of the machine, and after that they could change with another one.